Hey students, so now please put everything down, and please enjoy the brief introduction of the new Unit 10, talking about exponential functions, and we'll give it a chance.
Overview of logarithms. Unfortunately, there's a little quirky story in the history that makes us use the word logarithm over a much simpler word, which would make this topic entirely so much less scary for students. Let me give you that history. In the 1400s and 1500s, scientific work was really going great guns. And scientists were often collecting data, and they'd get, they're measuring something like the motion of a star, and they found its position as at some value of 3.159 degrees above the horizon one night, and that's 3.128 the next night, and 3.414 something next night, and so on. So they'd often have these huge lists of data, and maybe they want to take the average to sort of round out any errors they had, and so that would involve these folks back in the 14 and 1500s, say, summing these numbers. And they'd be doing it by hand. There was no calculators around. Now that'd be a pain, but you could do it. It's not too bad to actually sum a list of numbers with, say, 3 decimal places or 6 decimal places or whatever. However, when you start doing formulas where you might want to multiply numbers as well, then things get mighty bogged down. Can you imagine what it'd be like, by hand, going 3.159 times 3.128, then times 3.1414 times. That is a truly tedious and horrendous process. And this really bogged scientists down way back in the 1400s, 1500s, and so on, early 1600s. So then came along a fellow by the name of John Napier, who really wanted to help out his colleagues. He was born in 1550, that's the best estimates we have, to 1617.
Mathematician John Napier, who lived from 1550 to 1617, was a Christian and an activist for the Reformation and Protestant affairs in Scotland. He also happens to be the inventor of logarithms, natural or Naperian logarithms. The number e forms the base of natural or Naperian logarithms. This limiting value is approximately 2.7182. It appears in the exponential function e to the x. It's the only function having a rate of growth equal to its size. In the language of calculus, the only function having a derivative equal to itself.
Hi. So after seeing the brief presentation about exponential functions, it is time for your exit slip. So take out a sheet of paper, fold it in half, and share it with your partner. Once you're done with that, there will be 2 questions. Very easy questions that you can get full credit. So easy way to get full credit on those. The 3rd question is going to be an extra credit. If you get that extra credit, you'll get those extra points. All right, so first question. After you share that half sheet of paper with your partner, one thing you know about exponential functions after seeing the trailer, after seeing the brief history and a couple of examples. So one thing, write to me one thing you know about exponential function. Question number 2. One thing that you're curious or excites you about the lesson. So I'll repeat that. Question number 2. One thing that you're curious or excites you about the lesson. And question number 3. You ready? That's the extra credit one. What is the name of the mathematician who invented logarithms, exponential functions? There's that one name. I'm looking for specifically of a mathematician who came up with all these great ideas about logarithms and exponential functions.